Okay, this is the demo for x86 part 1. This is Lucas Sproul. We're going to start by going through a couple simple commands. We can show that U 100 to 118. It's going to show what we just entered earlier. Speaking of entered, the command E, I'll say E 200 because we'll be changing those values later. Our 20, which I want to have stay. 01 because we're doing little endian. 50 and 2. That gives us our values of 120 and 250. Other command is D, or dump, or display, which will show us everything that we put in for our code. What else do we have? We have G. We put in G100. That just runs the program as expected. And then my last two commands we'll spend the most time on. So as shown earlier, we have our code right here, and we can expect to move 120 into DX, the value 120. I register 200 into AX and 202 into BX. Those are the values that we entered earlier with the E command. Subtract AX BX, jump if greater than or equal to. So this is a condition here. Add AX DX, and then again the command jump if greater than or equal to, and then the unconditional jump back to 10E, where we'll add AX DX again, and it'll keep repeating that loop until it does meet the condition, in which case it'll jump to 114, where we then assign AX into the register 200, and then the program terminates. So what I'm going to do is I'm going to show R. We have AX, BX, CX, and DX all have 0, and my pointer is 100, as seen here. I will begin with the trace command, which is the T key, and the first thing it's going to do is it's going to move 120 into DX. So I'll hit enter. Okay, so now we have 120 into DX. Next I'll move our register from 200 to AX, which is our value of, I believe we said it was 250 or 120. Oops. Next we're going to do the same thing, remove our other value, 250, into BX. And from here we subtract. So we're subtracting AX from BX, and then jump if greater than or equal to. Now right now our current value is 120, and that is not greater than. So as we go through, we're going to have to add DX to 120. And then it's still not greater than. So now we jump unconditionally back to add. So now we've added 120 to our value. And at this point it is greater than 250. So now we've moved it into 200, and our next command should be ending the program. And it is. That will be our next one after I hit T again. But I won't, because then I'll have to deal with reassigning a bunch of stuff like that. I don't want to. So now let's go ahead and reset the pointers. RIP back to 100, RAX to 0, RBX to 0, and RDX to 0. Alright, everything looks good. Now at this point I want to go ahead and change our values. I'm going to call E200. This time I'm going to make the register starting at 200 be 140. So that's just going to be 40, oh sorry, yeah, 40, whoops, let me change that. So that's just going to be 40, 01, I'll leave the 50, and then 4. So now our values are 140 and 450. So again, here we are, let's begin. So we are putting 140 into AX, 450 into BX, subtracting the two, which gets 450 minus 140 is 310, and then jump if greater than or equal to, and 140 is not greater than 450, so we're going to skip that condition. Then we're going to add DX, which is 120, as seen right here. Adding 120 to 140 gets us 260. and 260 is still not greater than 450. So we're going to skip that again. Jump unconditionally back to 10E, where we're going to add next. And there we are, we're adding. Now 120 plus 260 is now going to be 380. So now we have 380 in AX. 380 is still not greater than 450, so we'll skip that again. Jump unconditionally back to where we're going to add. Add 120 to 380 again, and now we have 500, which is greater than 450. So in our next line, jump if greater than, and now we do meet the condition, so now we're jumping to 114, which then will assign 500 into AX. And there we are, 500 back into AX, and then we're going to end the program. And there we are. So to recap, the basic commands: D dumps or displays our code, E is to enter or assign values, U unravels our code. To show one more time, our code was, and then putting these two numbers here, 100 to 118, specifies our start and end points, rather than unraveling more than what we actually need, more than what's necessary. Again, R shows our registers, G runs the program, and T traces step by step. And that's part 1 for x86. This is part 2 of x86. I'm Lucas Sproul. Right here I have my code used that I put together through my hand assembly, as seen here. So here's my code in hex form. I'm going to copy and paste it straight into debug. So let's open debug. And then we were instructed, I was specifically instructed to not use register D. So D is not used. D isn't used. I'm using CL as my random number, BL as my counter, and AL as my sprite number. Just to get that out of the way. So I was instructed to start at register 676. So start at 676. We'll just paste all that code in, and then let's go ahead and unravel 616 to 68E. So here's my code here. We're having the incrementer BL have an input of we're inputting a value of 20 into BL, and then the registers I'm using for AL and CL are 200 and 202, which we'll assign shortly. Then we'll subtract AL from CL. The condition jump greater than or equal to 68A down to here, where we will move AL into 200. And then if the condition is not met, add BL to AL, adding 20 to whatever value this is put in. And then we have their condition again to check. If it doesn't meet the condition, then we have an unconditional jump back to 684, where we will resume the loop again. And then we'll increment by BL, and we'll keep going through this loop right here until it meets this condition, in which case it'll jump to 68A greater than or equal to, where finally AL will be moved back into 200, and then we will terminate the program as expected. So now I'm going to go ahead and I'm going to enter in our values. So for this example, I want to use values of 140 and 200 for 3 complete loops. So because it's a little endian, we'll put in 40, 0, 1, 0, 0, and 0, 2. And then just to show what our values are, I'll do D 200 to 203, and that shows my values are 140 and 200. So now at this point I do need to change my pointer, which defaults to 100 as seen here. RIP is 100, so I'll do our pointer is 100. So now I'll use the command RIP, and I will change that to 676 where we start, and now I'm where I need to be. And you can see that my next command is going to be moving 20 into BL. So I'll go ahead and trace that. Then we move 200 into AL. Next we move 202 into CL. Now before I go any further, we're going to see a problem here, because when I use the R command, it shows AX, BX, CX, and DX by default. It does not show AL, BL, CL, or DL. Now that I'm using DL for this example, I'm only using AL, BL, and CL. So these values for AX are not correct. I couldn't find a way to make it function properly, but I'll go ahead and continue with the trace for the sake of the demo. Subtract AL from CL. Now, however, AL and CL we cannot see here on the register, so I'm not sure what is happening at this point. But we'll trace through again, jump if greater than or equal to. Now, this should be referring to AL if it's greater than or equal to. However, it seems to be referring to some other value, as it's showing AX and BX here, not AL and BL. So at this point, it does jump, unfortunately, because the condition is met. It believes that AL is greater than BL, but it's actually referring to two different values. So then the program just terminates, and that's all I have for part 2. This is the demo for part 3 of x86. I'm going to be brief here and just say MASM has been giving me problems lately. I've lost my code and had to redo the VMware. I was having a problem accessing the .lst files. So I don't have any demo to show for MASM. I tried getting it to work and running through my program using the same that I got from assembly. However, I was not able to get the code up and running on MASM.